This graph meets in 2 points. That means number of zeros is 2. Number of zeros is 2. Where r of x equal to 0 or degree of r of x always less than degree of g of x. This r of x is actually the remainder. So that is always, degree is always less than g or degree of the g of x. So you have to by heart these two formulas. They are sum of the zeros and the product of the roots. Then only we can find out the values of a and c here. Okay, you remember this formula. Hi dear students. Today we are going to discuss our second chapter in your NCERT book, 10th NCERT book, Polynomials. Chapter 2, Polynomials. At first we are going to explain the theory parts of this chapter. Then we will do some questions. Okay. Key concepts, types of polynomials. The first, our types of polynomials. Actually, what is a polynomial? A polynomial contains some constants, a0, a1, a2, etc. and variables like x, y, z, etc. But in this chapter, in our syllabus, only one variable type polynomials. That means it can be x or y or z or p or q, etc. The fundamental form of a polynomial is a0 plus a1x plus a2x square plus etc. plus an x raised to n. This is the fundamental form of a polynomial. Here, a0, a1, a2, etc., an are constants, are real constants or constants, real numbers. a1, a2, etc. are real numbers. But the power of x, that means here, actually here it is x raised to 0, but x raised to 0 is 1. X raised to 1, x square, etc., x raised to n. The index of the variable is always an integer. It can be 0 also. That means it can be x raised to 0, x raised to 1, x square, etc., x raised to n. This is not possible. X raised to 1 by 2, it is not possible. X raised to negative 1, it is not possible. X raised to minus 2, etc. It is not possible. Only integers, positive integers including 0. The power of the variable is always. This is an nth degree polynomial. How we can recognize the degree of a polynomial? The degree of a polynomial means the highest power of the variable denotes the degree of the polynomial. For example, 2x plus 3, it is a polynomial, not 0, then it will be an equation, 2x plus 3. It is a polynomial. The polynomial is usually denoted by the letter p of x. P of x means a polynomial with the variable x. Suppose p of x is equal to 2x plus 3. Here, the highest power of x is 1. So, degree of p of x is 1. Degree of p of x is equal to 1. 2 and 3 are the real constants. The coefficients or the constants can be any real number, no problem. But the power of x is not any real number. The power of x is always an integer, including 0. This is not a polynomial. 2 root x plus 3. It is not a polynomial. It is not a polynomial because here the power of x is 1 by 2. It is not a polynomial. This is called first degree polynomial or linear polynomial or linear polynomial. linear polynomial. 2x plus 3. It is a first degree polynomial or linear polynomial. That is called linear polynomial. Degree 1. Degree of the polynomial is 1. Degree means the highest power of the variable, highest index of the variable. It is called linear polynomial. Then another second degree polynomial. Second degree polynomial or quadratic polynomial. Quadratic polynomial. First, what was first degree polynomial? First degree polynomial is 2x plus 3. This is the example for a first degree polynomial. Fundamental form of first degree is p of x is equal to ax plus b, where a not equal to 0. Fundamental form of the linear polynomial or first degree polynomial is p of x is equal to ax plus b, where a not equal to 0. A is not, if a is equal to 0, it is of a degree of the polynomial 0. It is only a constant. So you clearly mention that a not equal to 0. Then what is the second degree polynomial? For example, firstly I can give you example 2x square plus 1. It is a second degree polynomial, or sum 3x square plus x. It is also a second degree polynomial, or sum 5x square. It is also a second degree polynomial. And another example 3x square plus 2x minus 1. 3x square plus 2x minus 1, it is a second degree polynomial. Second degree polynomial is also called quadratic polynomial. Second degree polynomials are also called quadratic polynomial. Here the highest power is 2, here the highest power is 2, here the highest power is, here also the highest power is 2. When a polynomial, if the highest power of the variable is 2, then we can say that it is a second degree polynomial or a quadratic polynomial, right? Okay. Then what is the fundamental form of a quadratic polynomial? The fundamental form of a quadratic polynomial is p of x is equal to ax square plus bx plus c, where a not equal to 0. This is the fundamental form of a quadratic polynomial. P of x equal to ax square plus bx plus c, where a not equal to 0. So quadratic polynomial here, some more examples are here: x square plus 5x minus 6, 2x square plus 3x minus 5, etc. And next is cubic polynomial. Next is cubic polynomial. From the word cubic, we can understand what do you mean by cube, cubic. Cubic means third degree. Third degree polynomials. Third degree polynomials or cubic polynomials. Third degree polynomials or cubic polynomials. Here the highest power is how much? 3. The highest power is 3. For example, p of x is equal to 3x cube, or p of x is equal to x cube plus 1, or p of x equal to x cube plus 3x square plus 1. These are some example. Or p of x equal to 5x cube plus 6x square plus 2x plus 1. These are some examples of third degree polynomial or cubic polynomial. The fundamental form is p of x is equal to ax cube plus bx square plus cx plus d, where a, b, c, d are real numbers. A, b, c are real constants. Here the highest power is 3, where a not equal to 0. Where a not equal to 0. This is the fundamental form of a cubic polynomial. Some more examples are here. Degree 3 cubic polynomial, or third degree polynomial, x cube minus 4x, 3x cube minus 5x square minus 11x minus y minus 3, etc. These are some examples of cubic polynomial. Similarly, fourth degree polynomial. What is a fourth degree polynomial? Fourth degree polynomial. Fourth degree or biquadratic. Fourth degree polynomials are also called biquadratic polynomial. Biquadratic. For example, p of x equal to 3x raised to 4 plus 5x square plus some 2x plus 1, or p of x is equal to 5x raised to 4 plus 3x cube plus 5x square plus 2x plus 3. These are some examples of a fourth degree polynomial or biquadratic polynomial. General form is p of x is equal to ax raised to 4 plus bx cube plus cx square plus dx plus c, where a not equal to 0. This is a fourth degree polynomial or biquadratic polynomial. These are the various types of the polynomials, and the degree greater than 5 or 5, 6, etc. Generally, we can say that they are polynomials. The first four polynomials have the particular names. When degree is equal to 1, it is called a linear polynomial. When highest degree is 2, it is called a quadratic polynomial. When the highest power is 3, it is called a cubic polynomial. When the highest power is 4, the polynomial is called biquadratic polynomials. All others are generally, we can say that generally we called it is polynomials, just polynomials. Okay. Then what is an nth degree polynomial? Similarly, nth degree polynomial. Here the highest power is n, x raised to n. This is the general form of an nth degree polynomial where a(n) not equal to 0. a0 plus a1x plus a2x square plus etc. plus an x raised to n. It is called an nth degree polynomial where an not equal to 0. N cannot be 0. These are the fundamental concept of polynomials. Okay. The next is value of a polynomial. Actually, value of a polynomial, for example, suppose p of x is equal to, I can explain with an example. Suppose p of x equal to some 2x minus 1. Suppose x is equal to 1. Then p of 1, you just put 1 for x. Right hand side 2 into 1 minus 1. That is 2 minus 1 equal to 1. This is called value of the polynomial when x is equal to 1. Simple. This is called the value of the polynomial when x is equal to 1. Example. Another example. Suppose p of x is equal to x square plus 6x minus 5. X square plus 6x minus 5. Value of at x is equal to 2. That is p of 2 equal to 2 square plus 6 into 2 minus 5. 2 square plus 6 into 2 minus 5. This is equal to, what is 2 square? 4 plus 12 minus 5. That is 4 plus 12 is 16 minus 5 equal to 11. This is called value of the polynomial. Generally, we can say that the value of the polynomial p of x at x is equal to k. Here it is x equal to 1. Here it is x is equal to 2. Okay, is obtained by substituting x is equal to k in the polynomial. Here we substitute x is equal to 1 in the polynomial. Here we substitute x is equal to 2 in the polynomial. So this is called value of the polynomial. Okay, this is called value of the polynomial. Again, one more example I can give you. P of x is equal to x square minus 5x plus 6. What is the value of the polynomial at x is equal to minus 2? Can be plus also, x equal to minus 2. That is P of minus 2 is equal to minus 2 square plus 5 into minus 2 plus 6. Minus 2 square is 4. This is minus 10 plus this is 6. This is equal to 4 plus 6. 10 minus 10 equal to 0. Here the value of the polynomial at x is equal to minus 2 is 0. This is called value of the polynomial. Okay. And another concept. The real number k is called zeros of a polynomial. A very important section. I can explain with an example. Then again I will explain the theoretical part. That is a simple method, I think. Okay, look here. Suppose P of x is equal to x square minus 5x plus 6. Suppose P of x is equal to x square minus 5x plus 6. You just find P of 2. What is P of 2? That is 2 square minus 5 into 2 plus 6. That is 4 minus 10 plus 6. That is 10 minus 10 equal to 0. When we substitute a value for x, then the value of the polynomial is equal to 0. Then we can say that 2 is a 0 of this polynomial. Here, x equal to 2 is a 0 of the polynomial P of x. X equal to 2 is the 0 of the polynomial P of x. That means when x is equal to 2, P of 2, that is equal to, when x is equal to 2, P of 2 equal to 0. The y coordinate will be at x is equal to any value, the y coordinate will be is 0. Then we can say that this is the 0 of the polynomial. Okay. Again, take x is equal to 3. What is P of 3? In the same polynomial, 3 square minus 5 into 3 plus 6. 3 square is 9 minus 15 plus 6. That is 15 minus 15 equal to 0. Take. That means at x is equal to 3, again the value of the polynomial is 0. Therefore, 3 is also 0 of the polynomial. Already we have 2 is a 0 of the polynomial. 3 is also 0 of the polynomial. Some properties are here, arise here. First one is, for a second degree polynomial, we can expect a maximum of 2 zeros. The number of zeros depends on the degree of the polynomial. If degree is 2, the number of zeros will be 2. You always remember that. For a first degree polynomial, look here. Suppose P of x is equal to x minus 3. What is the 0 of the polynomial? It is very clear that put x is equal to 3. 3 minus 3 is 0. So P of 3 is equal to 3 minus 3 equal to 0. Therefore, we can say that x equal to 3 is a 0 of this polynomial. This is a first degree polynomial. The only 0 is when x equal to 3. So we can conclude that for a first degree polynomial, there will be number of zeros is 1. For a second degree polynomial, there is the number of zeros is 2. Similarly, suppose the polynomial is a third degree, we can expect the number of zeros is 3. So For an nth degree polynomial, the number of zeros will be n. Number of zeros will be n. That is very important. A polynomial of degree n can have at most n zeros, can have never greater than n zeros. That is so max to most n zeros. For a second degree polynomial, we can expect the maximum of 2 zeros. For a third degree polynomial, we can expect a maximum of 3 zeros. Zeros means the value of the polynomial is equal to 0 at which x is equal to k. Then we can say that k is a 0 of a polynomial. This is the definition. Here, with examples, through here, p of x equal to x square minus 5x plus 6. What is p of 2? When substitute the x 2 for x, we get the value is 0. So we can say that x equal to 2 is a 0 of the polynomial. That is the concept of 0 of the polynomial. Sometimes zeros are also called roots. If it in equations we say that instead of zeros, roots or solution, roots or solutions. That is for equations. Okay, that's later we will discuss it. Okay, here you just remember zeros. So what? So again, suppose p of x is a polynomial. If p of k is equal to 0, that means at x is equal to k, that is p of x equal to 0, then we can say that k is a 0 of the polynomial. Okay. Geometrically, we can find that. So here I can give a graph, x-axis, y-axis. Suppose this is the linear polygraph. Graph of a linear polynomial is always represent a straight line. This graph, this straight line intersect at x-axis. That means here at x-axis y coordinate is 0. At x-axis y coordinate is 0. So that means at the value of x, value of p of x. Actually, this ordered pair is of the form x comma p of x. At x equal to some value, the value is 0. So this is called 0 of the polynomial. So number of zeros is 1. How we can find out number of zeros graphically? The graph of a polynomial, if it crosses only through one point x-axis, then number of zeros is 1. If it passes through, suppose I can give another example. This is a graph of a polynomial. This graph, actually it is a parabola, it is a graph of a second degree. Later we will discuss. At x-axis, this graph meets in 2 points. That means number of zeros is 2. Number of zeros is 2. And suppose another graph, I can give another graph. This is the graph of another function. Number of zeros. Number of zeros means the number of points the graph crosses the x-axis. This is 1, 2, 3, 4. So number of zeros is 4. Graphically we can find out like that. The given graph meets the x-axis in here it is 4 points. So we can say that number of zeros is 4. Here number of zeros is 2. Another graph. I can give another graph. This is the graph of another function. Here this graph crosses 1, 2, 3. So number of zeros is 3. You just remember this idea also. Okay, like that. Geometrical meaning of zeros. For a linear polynomial ax plus b, the graph is a straight line that intersects x-axis at only one point. Already we have discussed it. Okay. And how we can find out the zero? Ax plus b. P of x is equal to ax plus b. And how we can find out the zero of the polynomial? That is very simple. You just take P of x equal to 0. That is ax plus b equal to 0. Ax is equal to minus b. X is equal to minus b by a. This is the zero of the polynomial ax plus b. Another example, P of x is equal to 2x minus 4. How we can find out the zero of the polynomial? You just take P of x equal to 0. That is 2x minus 4 equal to 0. 2x equal to 4. X equal to 4 by 2, that is 2. X equal to 2. This is the zero of this polynomial. This is the method of finding zero of a polynomial, right? For a first degree equation, for a first degree polynomial, there exists only one zero. Okay. And another concept. And another concept. For a quadratic polynomial means P of x is equal to ax square plus bx plus c. This is the quadratic polynomial. The graph is always a parabola like this. Number of zeros is 2. Graph is always a parabola. Number of zeros is 2. For example, P of x is equal to sum x square plus 5x plus 6. X square plus 5x plus 6. So, how we can find out the number of zeros or zeros of a polynomial? You just take P of x is equal to 0. This implies x square plus 5x plus 6 equal to 0. You factorize this. How we can factorize this polynomial? You just take two numbers whose product 6 and sum 5. What are the numbers? 2 and 3. 2 into 3, 6. 2 plus 3, 5. You just find out two numbers whose sum is 6 and whose product is 6, sum is 5. You always check whether the coefficient of x square is 1 or not. This method is possible only when the coefficient of x square is 1. Okay, right? So we can write it as x plus 2 into x plus 3 is equal to 0. X plus 2 into x plus 3 is x square plus 5x plus 6. This implies x plus 2 equal to 0 or x plus 3 is equal to 0. Product of two factors are 0 only when at least one of them will be 0. It is a fundamental rule in mathematics. That means x plus 2 equal to 0 or x plus 3 0. That is x equal to minus 2 and here it is x is equal to minus 3. These are the zeros of the polynomial x square plus 5x plus 6. Okay, I can give you another example also. Suppose P of x is equal to x square plus 4x plus 3. X square plus 4x plus 3. It is also a quadratic polynomial. The shape of the parabola is, the shape of the graph is a parabola. It crosses 2 points in x-axis. So number of zeros will be always 2. Okay. So what is this? We can factorize this P of, first you take P of x is equal to 0. That is x square plus 4x plus 3 is equal to 0. X square plus 4x plus 3 is equal to 0. Assume two numbers. First you check whether the coefficient of x square is 1 or not. It is 1 only, we can apply this method. So, assume two numbers whose product 3 is sum 4. What are the numbers? 1, 3. 1 into 3, 3. 1 plus 3, 4. Therefore, how we can factorize this? x plus 1 into x plus 3 is equal to 0. That means either x plus 1 equal to 0 or x plus 3 is equal to 0. That is x is equal to minus 1. That is 1, 0. Here it is x equal to minus 3. That is another 0. Okay, these are the zeros of this polynomial, negative 1 and negative 3. When we put negative 1 and negative 3 here, the value will be always 0. Here also, when we put x is equal to minus 2 or minus 3 here, the value will be always 0. That means 0 of the polynomial. And similarly, for a cubic polynomial, the graph can have at most 3 points of intersection with the x-axis, at most 3 zeros, etc., etc. Then next, for a quadratic polynomial, very, very important, the relationship between zeros and coefficients. Look here. Suppose p of x is equal to ax square plus bx plus c, where a not equal to 0. This is called a quadratic polynomial. This is called a quadratic polynomial. Suppose alpha and beta are zeros of the polynomial. Alpha and beta are the zeros of that is p of alpha is equal to 0, p of beta is equal to 0. That is from our fundamental concept. If alpha beta are the zeros of the polynomial, then it is very clear p of alpha is equal to 0, p of beta equal to 0. That is already we have discussed it. Okay, then here a, b, c are the coefficients, real coefficients. Here a comma b comma c are coefficients of p of x. Then alpha plus beta, sum of zeros is equal to, very important formula, minus b by. It is a formula. That is coefficient of negative coefficient of x divided by coefficient of x square. That is very important concept. Sum of these zeros is equal to, you just remember this result, minus coefficient of x divided by coefficient of x square, or minus b by a. Similarly, product alpha beta is equal to constant term divided by coefficient of x square, that is c by a. Very important formula, two formula. Alpha plus beta minus b by a, alpha beta c by a. I can give an example. Suppose p of x is equal to 2x square plus 3x plus 4. Alpha beta are zeros. Then alpha plus beta is minus b by a. That is ax square plus bx plus c form. Here what is a? Here in the place of a is 2, in the place of b is 3, in the place of c is 4. Alpha plus beta minus b by a, that is minus 3 by 2. Alpha beta c by a, that is 4 by 2, that is 2. Very, very important formula. Sum of the zeros, alpha plus beta minus b by a, product of zeros, alpha beta c by a. Very, very important formula. You write the example also. And I can give another example. X square minus 5x plus 6. P of x equal to x square minus 5x plus 6. Compare with ax square plus bx plus c. What is a coefficient of x square? 1. What is B? Coefficient of x, that is minus 5. What is C? 6. Suppose, therefore, alpha plus beta minus B by A, that is minus negative 5 by 1, that is minus 5 plus 5. What is alpha beta? Alpha beta is C by A, that is 6 by 1 equal to 6. Alpha plus beta minus B by A, alpha beta C by A. Okay, right? So for a second degree polynomial, there exists at most two zeros. Suppose it is alpha and beta, then sum of the roots alpha plus beta is equal to minus B by A, and product of the roots is equal to C by A. This is very important formula. Okay, you remember always this formula. Okay, then cubic degree, we can take the cubic degree polynomial. Cubic degree polynomial. What is the cubic degree polynomial? Already we discussed it. The standard form of a cubic degree polynomial, that is P of x equal to ax cube plus bx square plus cx plus d, where a not equal to 0. This is the standard form of a cubic polynomial. Since it is a cubic polynomial, we can expect the maximum of at most 3 zeros. Let us take alpha, beta, gamma are the zeros of P of x, are the zeros of P of x. Therefore, sum of the zeros alpha plus beta plus gamma, here it is again minus B by A, or negative coefficient of x square divided by coefficient of x cube. And next is alpha beta plus beta gamma plus gamma alpha equal to, that is C by A, positive C by A, that is coefficient of x divided by coefficient of x cube. Alpha beta plus, very very important formula. First formula regarding the third degree polynomial, alpha plus beta plus gamma minus B by A, that is minus coefficient of x square divided by coefficient of x cube. Alpha beta plus beta gamma plus gamma alpha, that is equal to positive C by A. First is negative, second is positive C by A, that is coefficient of x divided by coefficient of x cube. One more formula, product of the roots alpha, beta, gamma, that is minus D by A. First is negative, then positive, then negative. You always remember this order of the sign. First is positive, first is negative, second is positive, third is again negative. That is negative constant term divided by coefficient of x cube, negative D by A. These are the formula with respect to the third degree polynomial. Formula with respect to third degree, three formula. One is alpha plus beta plus gamma, that means sum of the zeros. Second is alpha beta plus beta gamma plus gamma alpha, that is C by A. Then alpha beta gamma, that means simply we can say that product of the zeros, that is minus D by A. Always remember about the sign also. First is negative, second is positive, third is again negative. Okay, we can explain with some examples. Suppose P of x is equal to x cube plus 2x square plus 4x plus 3. So first you compare with the standard form. What is say? Compare with this. A is equal to 1, B equal to 2, C equal to 4, and D is equal to 3. Suppose alpha, beta, gamma are zeros of the polynomial P of x. That is, what is alpha plus beta plus gamma? That is minus B by A. Minus B, that is minus 2 by 1. minus 2. A is 1. Then next is alpha beta plus beta gamma plus gamma alpha. That is C by A, positive C by A. That is 4 by 1 equal to 4. Then product of the zeros, alpha, beta, gamma, that is negative D by A, minus D by A. That is D is 3, minus 3, by 1, minus 3. This is the formula explained here. This is the detailed explanation, and this is the summary of this section. This is the detailed explanation. We will do more questions later, no problem. Okay. And division algorithm for polynomials. Division algorithm for polynomials. For any number, ordinary number, for example, 4 by 3, that is 4, 3 in one time, that is 3 into 1, 3, remainder is 1. Remainder is 1, that is 4 by 3 is equal to 4 plus 1 by 3. Actually, this is the meaning. 4 plus 1 by 3. This is the meaning. Or you multiply with both sides 3. 4 is equal to the ordinary numbers. This is the method of division. So, P of x and G of x are two polynomials with G of x not equal to 0. Then there exists the polynomials Q of x and R of x such that P of x is equal to G of x into Q of x plus R of x, where R of x equal to 0 or degree of R of x always less than degree of G of x. This R of x is actually the remainder. So that is always, degree is always less than G or degree of the G of x. Okay. This is called a division algorithm. Yes, next is again the summary of this class. Important formulas and results. Already we have discussed it. A polynomial of degree n has at most n zeros for a first degree polynomial, number of zeros 1, for a second degree polynomial, number of zeros maximum 2, for a third degree polynomial, number of zeros at most 3, etc. etc. Okay. If k is a zero of the polynomial p of x, then x minus k is a factor of p of x. That is very important. Suppose p of x equal to x square minus 5x plus 6. Here, p of 2 equal to 0. Is it correct? 2 square minus 5 into 2 plus 6. 10 minus 10, 0. Here we can say that x minus 2 is a factor of p of x. X minus 2 is a factor of p of x. If p of 2 equal to 0, that is called, actually it is called factor theorem. Okay. Already we have discussed in lower classes. If in the polynomial p of x, x square minus 5x plus 6, if p of 2 equal to 0, then x minus 2 is a factor of p of x. Same meaning. If k is 0 of the polynomial, if k is a 0 of a polynomial p of x, then x minus k is a factor of p of x. No problem. Already we have discussed this also for a quadratic polynomial ax square plus bx plus c. Sum of the zeros minus b by a, product of zeros, c by a. Similarly, for cubic polynomial, then finding a polynomial with the given zeros. The zero, suppose zeros alpha and beta, p of x equal to k into x minus a into x minus b. So say a formula. Suppose p of x equal to ax square plus bx plus c, a not equal to 0. Suppose alpha and beta are the zeros of the polynomial, then this p of x can be expressed as some constant k into x minus alpha into x minus beta. That is the meaning of this. Okay. Because x minus alpha and x minus beta are the factors of this polynomial, since alpha and beta are the zeros of this polynomial. Then, remainder theorem. Already we have discussed it. If the polynomial p of x is divided by x minus a, then p of a is equal to 0. Then the remainder is p of a. If the remainder p of a is equal to 0, x minus become a factor of p of x. If a polynomial p of x is divided by x minus a, then the remainder is p of a. Factor theorem, that is the reverse of remainder theorem. If x minus is a factor of the polynomial p of x, if and only if p of a is equal to 0. Okay, I can give you an example also. This is an example. P of x equal to x square minus 5x plus 6. P of 2 equal to 0, right? P of what is P of 2? P of 2 is, you substitute here, 2 square minus 5 into 2 plus 6. That is equal to 0. So we can say that x minus 2 is a factor of P of x. That is this concept. If x minus is a factor of P of x polynomial, if and only if P of a is equal to 0. Here P of 2 equal to 0. So we can say that x minus 2 is a factor of P of x. Okay. These are the main important points, the most important points of this chapter. And again, we will do some more questions. Okay, we will do some more questions. I can give you a question regarding this chapter. You write a question, find a question from your NCERT book. Find the zeros of the quadratic polynomial x square minus 2x minus 8 and verify the relationship between the zeros and coefficients. Okay. First, take the given polynomial as p of x. This is the solution. First, take the given polynomial as p of x. Since it is a second degree polynomial, we can expect a maximum of 2 zeros. So factorize this. How we can factorize this? Assume two numbers whose product minus 8, sum minus 2. That is minus 4 and 2. Check it. Minus 4 into 2 minus 8. Minus 4 plus 2 minus 2. Correct. So this can be x minus minus 4 into, this can be x minus 4 into x plus 2. Minus 4 and plus 2. Assume two numbers whose product minus 8 and sum minus 2. That is, it is very clear that the numbers are minus 4 and 2. So x plus minus 4, x plus 2. X minus 4 into x plus 2 will be always x square minus 2x minus 8. So these are the factors. For finding the zeros, you just take p of x equal to 0. That is, x minus 4 into x plus 2 is equal to 0. This implies x minus 4 equal to 0 or x plus 2 is equal to 0. Take negative 4 into right hand side, x equal to 4, or here take plus 2 into right hand side, that is x equal to minus 2. So the zeros of p of x are, so the zeros of p of x are 4 and minus 2. This is the first part of the question, the zeros and 4 and minus 2. Then sum of its zeros equal to 4 plus minus 2, 2. Using equation alpha plus beta minus b by a, using the equation sum of the zeros is minus b by a. From this, what is this is a, this is b. So that is minus 2 by 1, that is again 2. Already we have got it. The sum of its zeros 2. Using the formula also we get again 2. Both are same. Alpha plus beta is equal to 2. Similarly, product of zeros is equal to 4 into minus 2, that is minus 8. Using equation product alpha beta equal to c by a. What is c by a? This is c. Coefficient of x square is, that is a 1. That is minus 8 by 1, that is minus 8. Also we get product minus 8. Using the already we got the zeros are 4 and minus 2. Directly we can find out sum of the zeros and product of the zeros from this result. Also we get, using the formula, sum of the roots is same as this method. So both are same. This is the verification. This is the verification of the relationship between the zeros and the coefficients. Zeros and the coefficients. Okay. Okay, tomorrow we will discuss some more questions from this chapter. Some previous year's questions from your NCERT book also, NCERT book questions. In the next class we will discuss some questions from this chapter. Most of them are your previous year's questions and from your textbooks, NCERT textbooks also. So you revise this theory part once again, you by heart the formula, then only we can do the problems. Okay, so today we revise once again this chapter and by heart the formula. Okay, thank you all. Hi children, yesterday we discussed the theory parts of this chapter. Today we are going to discuss some NCERT book problems. Our first question is, find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the coefficients. Yesterday we discussed what is a quadratic polynomial. There is a polynomial is of the form ax square plus bx plus c, p of x equal to. That means second degree polynomial. What are the properties of a second degree polynomial? Suppose alpha, beta are the zeros of the polynomial, then alpha plus beta equal to minus b by a, alpha beta equal to c by a. This is the very important property regarding the zeros of a polynomial, second degree polynomial. Sum of the zeros equal to minus coefficient of x divided by coefficient of x square. Product alpha beta is constant term divided by coefficient of x square. This is the fundamental result. Okay. Then the zeros are p of alpha and the value of zeros, that is P of beta. If alpha, beta are the zeros, then the value is P of alpha and P of beta. Okay, no problem. The first question, we have to find out the zero of the polynomial. That is, take it as P of u. P of u is equal to 4u square plus 8u. Instead of x, here u, that is only. P of u is equal to 4u square plus 8u. Yes, how we can find out the zeros of the polynomial? Yesterday we discussed it. Put or take P of u equal to 0. That is 4u square plus 8u equal to 0. Here 2u is a common factor. That is, here it is 4u is the common factor, 4u. That is, we can take 4u into outside, that is u plus 2. That is equal to 0. This implies 4u equal to 0 or u plus 2 equal to 0. This implies u equal to 0 or u is equal to minus 2. These are the zeros of the polynomial 4u square plus 8u. We can take, suppose that is alpha equal to 0. Second 0, suppose beta equal to minus 2. These are the answers of the first part. Find the zeros of the following quadratic polynomial. That is, this is the answer. 0, comma, negative 2 are the zeros of the polynomial. Then the next part, and verify the relationship between the zeros and the coefficients. That is, alpha plus beta. Sum of the, from this we get alpha plus beta, that is 0 plus minus 2. That is negative 2. Look here, directly we can find out. Here P of u is equal to 4u square plus 8u can be constant term absent. We can put a 0 here, no problem. P of u equal to 4u square plus 8u, that is given. But the standard form is ax square plus bx plus c, a constant term also. But here it is 0. We can put it as 0, no problem. There is alpha plus beta is equal to minus b by a. Directly we can find out from here, that is minus 8 by 4 minus b by a, minus 8 by 4. What is minus 8 by 4? Minus 2. And product alpha beta. Alpha beta is equal to 0 into minus 2. That is 0. That is, here it is c by a, 0 by 4. Alpha beta c by a, 0 by 4. That is again 0. Therefore, it is verified. It is verified. Okay, right? This is the method. You can expect this type of questions in your board exams, 10th board exams. Okay? And our next question. Look here. This is the fundamental result. P of x is equal to ax square plus bx plus c. This is the theory part of this section. Okay. And our next question is P of t. That is t square minus 15. So, how we can find out the zeros? You just take P of t equal to 0. This implies t square minus 15 equal to 0. This implies t square equal to 15. This implies t is equal to plus or minus root 15. So, zeros are alpha is equal to root 15, beta equal to minus root 15, plus or minus. Okay, therefore, sum of zeros, that is alpha plus beta, root 5, 15 plus minus root 15, that is equal to 0. Product alpha beta is equal to plus or minus root 15 square, that is again 15. So the standard form is, here the first degree term is absent, t square plus 0t minus 15. This is the standard form. This is the standard form. Okay, then how we can verify it? So the zeros are alpha, beta. Alpha is, what is alpha? Root 15. That is root 15 into minus root 15. That is minus 15. This is the product. Directly we can find out alpha plus beta. That is minus b by a 0 by 1 0. That is correct. And alpha beta, that is c by a minus 15 by 1, that is minus 15. That is also correct. Okay, this is the method. Okay, what is the next one? This is a very important question, repeated question in your board exams. Nearly 4 or 5 times this question is asked. Okay, 6x square minus 3 minus 7x. How we can find out the zeros of this polynomial? P of x is equal to 6x square minus 3 minus 7x. First you rewrite in its standard form. First is second degree, then first degree, then after the constants. 6x square minus 7x minus 3. How we can factorize here the coefficient of x square is 6, not 1. So in the lower classes, in classes 8 or 9, already you have studied about it. How we can factorize this? How we can factorize it? So for finding 0, our first step is p of x equal to 0. That is 6x square minus 7x minus 3 equal to 0. How we can factorize it? Assume two numbers whose product is 6 into minus 3. 6 into minus 3 minus 18. Sum negative 7. That is 6x square minus 9x plus 2x. Look here, minus 9 into 2 minus 18. Minus 9 plus 2 minus 7. This is the method of factorization. Minus 3 equal to 0. So you can take like this. Here what is the common factor? 3. X is the common factor. That is 2x minus 3 plus 2x minus 3 equal to 0. Again the common factor is 2x minus 3. 2x minus 3 into 3x plus 1 equal to 0. That is 2x minus 3 equal to 0. 2x equal to 3. X is equal to 3 by 2. From 2x minus 3 we get the root. And from next factor 3x plus 1 equal to 0. 3x equal to minus 1. X is equal to minus 1 by 3. So what are the zeros? Take alpha equal to minus 3 by 2. Beta is equal to minus 1 by 3. These are the zeros of the polynomial. X equal to 3 by 2 or x equal to minus 1 by 3. We can call first 0 alpha 3 by 2. Second 0 beta minus 1 by 3. Okay, this is the method of finding zeros of the given polynomial. This problem is very, very important problem. Okay, then directly we can find what is alpha plus beta. Alpha plus beta 3 by 2 plus negative 1 by 3. Take LCM and simplify. Alpha plus beta. What is alpha plus beta? That is 7 by 6. That is 3 by 2 minus 1 by 3. 3 by 2 minus 1 by 3. Take LCM. 9 minus 2 by 6. That is 7 by 6. 7 by 6. Directly we can find out from alpha plus beta minus 7 by 6. Minus 7 by 6. That is also 7 by 6. So this our answer is correct. Alpha plus beta minus b by a. Similarly, what is the product? Alpha beta. I can do here alpha beta, that is equal to alpha 3 by 2, beta minus 1 by 3, 3 by 2 into minus 1 by 3, 3 can be cancelled. That is negative 1 by 2. that is negative 1 by 2. Directly we can find out alpha beta c by a. C is minus 3. Minus 3 by 6. That is negative 1 by 2. Both are same. Okay, so it is correct. This is the method. What's the next question? Yes, some more questions. Find a quadratic polynomial, each with given numbers, as the sum and product of its zeros respectively. This is just a reverse question. In previous questions, the quadratic equations are given. We have to find out the zeros of the polynomial. Quadratic polynomials are given. We have to find out the zeros of the polynomial. In this question, the zeros are given. We have to find out the corresponding quadratic polynomial, right? Reverse question. So here, first take the first question. First question is, take it as alpha, that is 1 by 4, beta is equal to minus 1. Okay. The equation, the quadratic polynomial is alpha minus 1 by 4, beta minus 1. So, the quadratic polynomial is sum. We have to find out the quadratic polynomial. You remember one more, you have to remember one more equation. That is k into some constant k into x square minus sum of the zeros, take it as s, into x plus product of the zeros. This is the equation. When the zeros are given, the corresponding quadratic polynomial is, the formula is, k is any constant, k, some constant k into x square minus sx plus p. Okay, here given zeros are 1 by 4 and negative 1 are the given zeros. That is given. So, what is k and what is s? S is equal to alpha plus beta. S is equal to alpha plus beta. The given numbers as the sum and the product of. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros. Or directly given, not alpha and beta. Not alpha and beta, given that s is equal to 1 by 4, p is equal to minus 1. Given that s is equal to 1 by 4, p is equal to negative 1. So we can directly substitute the values of s and p here. That is, quadratic polynomial is k into x square minus 1 by 4x plus p, negative 1. Take LCM, k into 4x square minus x minus 4 by 4. 4 is the LCM. K into 4x square minus x minus 4 by 4. This is the quadratic polynomial. K is any constant, we can, so since k is any constant, if we take k is equal to 4, then quadratic polynomial is 4 into 4x square minus x minus 4 by 4. 4 can be cancelled. Finally, the quadratic polynomial is 4x square minus x minus 4. 4x square minus x minus 4 is the, since k is any constant, we can take it as k can be any real number, no problem. We can cancel a, then we will get the standard form. What is the standard form? Ax square plus bx plus c is the standard form. So how we can convert this into standard form? Take k is equal to 4. K can be any value, no problem. But here the denominator is 4. How we can cancel 4? For that, take k is equal to 4. 4 into 4x square minus x minus 4 by 4. 4 can be cancelled. You will get a quadratic polynomial in standard form, ax square plus bx plus c. This is the answer. Then next question. In the second question, s equal to 0, p is equal to root 5. S is equal to 0, p is equal to root 5. Then required quadratic polynomial is, then required quadratic polynomial is, required quadratic, for what is the formula? K into x square minus sx plus p. S means sum of the zeros, p means product of the zeros. This is the standard form. Okay. So this is equal to sum k into x square minus, here sum is 0, 0x plus p root 5. It is k into x square plus root 5. X square plus k into x square plus root 5. Taking k is equal to, here how we can cancel k? Taking, here the denominator is 1, so we can take k as 1. Taking k is equal to 1, the one such, therefore one such quadratic polynomial is x square plus root 5. One such quadratic polynomial is x square plus root 5. This is the answer. And another question. Third question. Third question. S is equal to root 2, that is given. P is equal to 1 by 3. Required quadratic polynomial is, what is the formula? K into x square minus xx plus p. This is the fundamental formula. K into x square minus sx plus p. That is, what is it? K into x square minus root 2x plus 1 by 3. Take LCM. That is k into 3x square minus 3 root 2x plus 1 by 3. Take LCM. Taking, we have to cancel 3. Then what will be k? Taking k is equal to 3. We get p of x is equal to 3 into 3x square minus 3 root 2x plus 1 by 3. We can cancel the 3. So this is equal to 3x square minus 3 root 2x plus 1. This is the answer. 3x square minus 3 root 2x plus 1. This is the answer. One more question. Fourth question. In the fourth question, what is this? S is equal to minus 1 by 4, product 1 by 4. Required quadratic polynomial is formula k into x square minus sx plus p. Second term will be always negative, k into x square minus xx plus p. So p of x is equal to k into x square minus 1 by 4x plus 1 by 4. That is k into x square plus 1 by minus plus 1 by 4. That is k into LCM is 4. 4x square plus x plus 1 by 4. Taking what will be k? We have to cancel this 4. So take k is equal to 4. Then p of x is equal to 4 into 4x square plus x plus 1 by 4. 4 can be cancelled. That is equal to 4x square plus x plus 1. This is the final answer. 4x square plus x plus 1. This is the method. Here, k is any arbitrary constant, any real number. So finally we have to cancel k. Then what is the denominator? Multiply. We can take the denominator as k, that will be cancelled. This is the final answer. The final answer is always of the form ax square plus bx plus c, where a, b, c are integers, integer coefficients. Okay. Next part. Next question. Find. What is the next question? If alpha and beta are the zeros of the quadratic polynomial, such that alpha plus beta is equal to 24 and alpha minus beta equal to 8, find the quadratic polynomial having alpha and beta as its zeros. Verify the relationship between the zeros and the coefficient of the polynomial. Okay, look here. Here, the fundamental form of the quadratic polynomial is p of x is equal to ax square plus bx plus c. Okay. Alpha, beta are the zeros. Here alpha, beta are the root zeros. Given that alpha plus beta is equal to 24. And what is alpha minus beta? That is 8. Take it as 1. Take it. We have to find out alpha, beta from this equation. So add 1 plus 2. 1 plus 2 becomes alpha plus alpha, 2 alpha. This is 0. That is 32. Alpha is equal to 32 by 2, 16. When subtract 1 minus 2, alpha 0, 2 beta. Beta minus beta, 2 beta. 24 minus 8, 16. Beta is equal to 16 by 2, 8. So alpha is equal to 16, beta is equal to 8. Then what will be the polynomial? What will be the polynomial? That is alpha plus beta. Alpha plus beta is, that is my, okay. Alpha is equal to 16, beta is equal to 8. Then what is the alpha beta? Alpha beta is equal to 16 into 8. Alpha beta is equal to 16 into 8, that is 128. 16 into 8 is 128. Required polynomial is k into x square minus sx plus p. S stands for sum, p stands for product. That is k into x square minus, sum is 24, 24x plus product is 128. Product is 128. So The answer is k into x square minus 24x plus 128. So we can take this the polynomial. K can be 1, no problem. X square minus 24x plus 128 is the required polynomial. Take k is equal to 1. K is any arbitrary constant. We can take k equal to 1, that is x square minus 24x plus 128. So how we can verify it? What is alpha plus beta? Alpha plus beta minus b by. This is of the form ax square plus bx plus c. This is of the form ax square plus bs plus c. Alpha plus beta is minus b by a. Here it is minus 24 by 1. That is 24. That is correct. That is given in the question, 24. Then what is alpha beta? Alpha beta is c by a. What is c? 128. 128 1. That is 128. Already we got it. Alpha beta 16 into 8. That is 128. Okay. This is the method of doing this question. Verify the relationship between the zeros and the coefficient of the polynomial. How we can verify? Use these steps. This is the verification part. This is the verification part. Okay, this is the first part of the question. First part of the question. And another question. If the sum and product of the zeros of the polynomial ax square minus 5x plus c is equal to 10, each find the value of a and c. Okay, here the given polynomial is ax square minus 5x plus c. Alpha plus beta, that is given as 10. Alpha beta is also 10. If the sum and product of the zeros of the polynomial ax square minus 5x plus c is equal to 10. Sum and product is equal to 10 each. So alpha plus beta is equal to 10. Alpha beta equal to 10. From this equation, what is alpha plus beta? Alpha plus beta minus b by a is the, suppose ax square plus bx plus c. Alpha plus beta we have minus b by a. Alpha beta equal to c by a. Here alpha plus beta minus 5 by a, that is 5 by a. And what is alpha beta? Alpha beta, that is c by a. That is c by a. As per question, 5 by a is equal to 10. C by a is equal to 10. From here we get alpha. Just cross multiply. 5 by 10 equal to a. A is equal to 1 by 2. Substitute here. C is equal to 10a. C is equal to 10 into 1 by 2. That is 5. Find the value of a and c. That is, a is equal to 1 by 2 and c is equal to 5. These are the answers. A is equal to 1 by 2, c is equal to 5. These are the answers. Okay. This is the method, very important type question. It's a previous question also. So, what is the formula used here? Alpha, suppose the quadratic polynomial is ax square plus bx plus c. Alpha plus beta is equal to minus ba. Alpha beta equal to c by a. This is the heart of this question. So, you have to by heart these two formulas. They are sum of the zeros and the product of the roots. Then only we can find out the values of a and c here. Okay, you remember this formula. Yes, next question. If one zero of a polynomial 3x square minus 8x plus 2k plus 1 is 7 times the other, find the zeros and the values of k. Okay. Here the given polynomial is p of x is equal to 3x square minus 8x plus 2k plus 1. Suppose alpha and beta are zeros of the polynomial p of x. And one more condition is given. Beta is 7 times alpha. If one zero of a polynomial is 7 times the other, what is its meaning? Suppose alpha is 1 0, then automatically second zero will be 7 alpha. Then that is 7 times of the first zero. Beta equal to 7 alpha. From we have alpha plus beta. Already we have alpha plus beta. Suppose again p of x equal to suppose ax square plus bx plus c. Suppose alpha beta are the zeros. Alpha plus beta equal to minus b by a. Alpha beta equal to c by a. Right? So this is the formula. So here, what is alpha plus beta? Alpha plus beta minus 8 by 3. That is 8 by 3. But beta is equal to 7 alpha. Alpha plus 7 alpha is equal to 8 by 3. What is alpha plus 7 alpha? 8 alpha equal to 8 by 3. 8 directly cancel. This implies alpha equal to 1 by 3. Alpha is equal to 1 by 3. Okay. And then what will be beta? Alpha 1 by 3. Use this equation, second root. Beta is equal to 7 alpha. Beta equal to 7 into alpha. What is alpha? 1 by 3. That is 7 by 3. So these are the find the zeros. Therefore, zeros of the given polynomial. Therefore, zeros of the given polynomial 1 by 3 and 7 by 3. 1 by 3 and 7 by 3. Then one more part, find the zeros, and next question is find the value of k. Find the value of k. Find the value of k. How we can find out the value of k? Look here. What is alpha beta? Alpha beta is c by a. The k lying on the constant in the constant part. So we can take this equation alpha beta equal to c by a. In our question, what is c? This is a. This is b. This part is c. 2k plus 1 is a constant. That is c. Compare with ax square plus bx plus c. C part is 2k plus 1. Alpha beta equal to c by a. That means from the given polynomial, alpha beta will be c by a. That is 2k plus 1 by 3. C is 2k plus 1. A is 3. Therefore, alpha beta is equal to c by a means 2k plus 1 by 3. But what is alpha beta? These are the zeros of the polynomial. Take it as this is alpha and this is beta. So 2k plus 1 by 3. From the question we got alpha beta is equal to 2k plus 1 by 3. From the zeros we got alpha 1 by 3, beta 7 by 3, then alpha beta is equal to 1 by 3 into 7 by 3. 1 3 will be cancelled. Both are in denominator. Then 2k plus 1 equal to 7 by 3. 2k plus 1 is equal to 7 by 3. Therefore, 2k is equal to 7 by 3 minus 1. Take LCM. 7 minus 3, 4 by 3. Therefore, k is equal to 2k is equal to 4 by 3. Then k is equal to 4 by 3 into 2. 2 cancel with 4 2 times. That is k is equal to 2 by 3. K is equal to 2 by 3. 2 by 3 is the answer. Very good question. You can expect in your board exams this type of questions. Actually, this question answered in previous years. CBSE 2012, 2016, 2017, 2021. Very, very important type question. 4 years already this question is asked. 2012, 2016, 2017 and 2021. Okay. Next question. If the zeros of the polynomial x square plus px plus q are double in value to the zeros of 2x square minus 5x minus 3, find the values of p and q. Okay. So, if the zeros of the polynomial x square minus ps plus q are double in the value of the zeros. So, first we have to find out the zeros of the polynomial 2x square minus 5x minus 3. First we have to find out the zeros of the polynomial 2x square minus 5x minus 3, p of x is equal to. So, how we can factorize this? Factorize this. Assume two values whose product is 2 into minus 3 minus 6, sum negative 5. Yes, what are the values? 2x square minus 6x plus x minus 3. 2 into minus 3 minus 6, correct? Minus 6x plus x minus 5x. Then club like this. Here 2x is the common factor, that is x minus 3 plus x minus 3. Again x minus 3 is the common factor. So x minus 3 into 2x plus 1. How we can find out zeros? Equate this, this is equal to 0. For finding the zeros, take x minus 3 equal to 0, x is equal to 3. And 2x plus 1 equal to 0, 2x is equal to minus 1, x is equal to minus 1 by 2. Therefore, zeros are 3 and negative 1 by 2. 3 and negative 1 by 2 are the zeros. And as per question, if the zeros of the polynomial x square plus ps plus q are double in the value of zeros of this, double the given polynomial x square plus x square plus ps plus q are double in the value to the zeros of 2x square minus 5x minus 3. Then what is the zeros of the, therefore, zeros of x square plus px plus q are double of 3 and double of minus 1 by 2. That is 2 into 3, then 2 into negative 1 by 2. They are 6 and negative 1. 2 into 3, 6. 2 into negative 1 by 2, that is negative 1. These are the zeros of the polynomial x square plus px plus q. Therefore, we have to find out p and q. Actually, these are the zeros of this polynomial. That is, suppose alpha plus beta. Alpha, beta are the zero of this polynomial. That is alpha, beta. Alpha plus beta is equal to minus p by 1 minus p. Suppose this is alpha and this is beta. So, from here alpha plus beta is equal to 6 plus minus 1, that is 5. Compare these both equations, that is, this implies minus p is equal to 5. Therefore, p equal to minus 5. P is equal to negative 5. Similarly, alpha into beta, that is C by A. Here C is Q, Q by 1. Q by 1 equal to Q. And directly we get alpha beta. Alpha beta 6 into minus 1 minus 6. Comparing these two terms, these two equations, directly we will get Q. Q is equal to minus 6. P equal to minus 5. Q equal to minus 6. These are the values of P and Q. Very good question. Once again, I can explain. Given that P of x equal to 2x square minus 5x minus 3, first we have to find out the zeros of the polynomial. That is, we have got x equal to 3, x equal to minus 1 by 2. They are the zeros of this polynomial. But as per question, or according to the question, x square plus ps, the zeros of p of x, the zeros of x square plus ps plus q are double the zeros of the given polynomial 2x square minus 5x minus 3. Therefore, what we will double 2 times. Take 2 times of 3 and minus 2. They are the zeros of this polynomial. That is 2 into 3 and 2 into minus 1 by 2 are the zeros of this given polynomial x square plus ps plus q. Okay, then take it as alpha and take it as beta. This 6 is alpha and beta is equal to negative 1. Suppose alpha and beta are the zeros of this polynomial, then we can find out that alpha plus beta is equal to minus b by a. Here what is b? P. What is a? Compare with the standard equation ax square plus bx plus c. Compare with the standard equation of the quadratic polynomial ax square plus bx plus c. We get in the place of b here, that is p. So alpha plus beta is minus b by a, means here a is 1. Therefore alpha plus beta is minus p by 1, that is minus p. Similarly, alpha beta is q by 1, that is q. But we have alpha is equal to 6 and beta is equal to minus 1. Therefore, what is alpha plus beta? 6 plus minus 1. 6 plus minus 1, that is 6 minus 1 is 5. That is alpha plus beta minus p. Minus p is equal to 5. Therefore, p is equal to minus 5. Similarly, what is alpha beta? Product of the roots, that is c by a. From this polynomial, we got q by 1. That is q by 1. Okay, that is q by 1. That is q. But directly we get alpha beta 6 into minus 1, that is minus 6. So equate these both alpha beta, we get q equal to minus 6. This is the method. Okay. Very important type question. Okay, I can give you one additional question that is not in the board. You can write it as, if the zeros of the polynomial x square plus px plus q, if the zeros of the polynomial x square plus px plus q look here, there is a correction in this question. For what value of k? For what value of k? The number negative 4. For what value of k? The number negative 4 is a zero of the polynomial x square minus x minus 2k plus 2 also find the other zero. CBSE 2012 question, 2017 question. For what value of k? The number minus 4 is a zero of the polynomial x square minus x minus in brackets 2k plus 2. Okay, here negative 4 is a zero of this polynomial. Given that negative 4 is a zero of this polynomial. Therefore, as per question, P of negative 4 equal to 0. What is P of x? We can take P of x equal to x square minus x minus 2k plus 2. As per question, P of negative 4 equal to 0. What is P of negative 4? P of negative 4 is equal to, you just replace x with negative 4, that is negative 4 square minus 4 plus 2k plus 2. This is equal to 0. What is negative 4 square? 16 plus 4. This is minus 2. This is minus of 2k plus 2. We can expand this bracket, or simply 2k plus 2 equal to 0. What is 16? 20 equal to 2k plus 2. Or 18 is equal to 2k. K is equal to 9. K is equal to 9. So we can substitute here. It is P of x is equal to x square minus x. K is 9, that is minus of 2 into 9 plus 2. That is x square minus x minus 20. 18 plus 2, 20. So one, we have to also find the other 0. First we have to find the value of k, that is, we got it, k is equal to 1. And the next part of this question, also find the other 0. Also find the other 0. Suppose alpha and beta are the zeros. Suppose alpha and beta are the zeros. Then alpha plus beta is equal to minus b by a. That is minus 1 by 1, that is 1. Here a is 1, b negative 1, c minus 20. Suppose alpha and beta are the zeros of this polynomial. Then we have alpha plus beta is equal to minus of b by a minus 1 by 1, that is 1. But one root is given. One root is given. Suppose let us take, let alpha is equal to minus 4. This simple, we have to find beta. That is minus 4 plus beta is equal to 1. Therefore, beta equal to 1 plus 4. That is, the other root is 5. The other root is 5. So both parts are completed. For the first part was k. What is the value of k? K is equal to 9. K is equal to 9. And the second part, we have to find out the second 0 also. First 0 is already given in the question, that is negative 4. Okay, that is alpha plus beta is from this polynomial. Alpha plus beta is equal to 1. But alpha, that is given in the question, minus 4 plus beta. Beta is the second 0 that we have to find. Minus 4 plus beta equal to 1. From this equation, what is beta? Take negative 4 into right hand side, we get beta equal to 1 plus 4, that is equal to 5. Okay. Okay, this chapter almost the subjective questions are completed. In the next session, we will discuss, that will be in live program. The next part, we will discuss some multiple choice questions from this chapter. NCERT book, almost 90% of the questions are completed. Difficult questions, every difficult questions we are discussed here. You can expect this type of questions in your board exams. In the next class, we will discuss a new chapter, third chapter. Okay, thank you all.